everyone. New week, new section, starting 2.6. Remember, we started this class with chapter 2, we jumped into chapter 9. Now we are back to chapter 2 again. We only had 2 sections in chapter 9. Linear systems, basically, 2 variables and 3 variables. Now in this chapter, we continue analyzing functions. And today, we will learn 8 basic functions you need to know by heart. Okay, their names and their graphs and their basic properties. And we will start shifting their graphs. Up, down, right, left, stretch, shrink. Okay, we will learn about transformations of these graphs. All these shifting translations are called transformations. Okay, we need to first understand the basic ones, main body functions, so we can start deforming them. Alright? So you already know majority of those, maybe a couple is missing, or you wouldn't know their names. Now we name them. The very first one is called a line, right? Y equals mx plus b. We've been dealing with, just before this section 2.5 was line equations. This is a straight line equation with slope m and intercept b, and of course the orientation can change. It goes downwards if the slope is negative. But such things are called linear function. Okay? And if x disappears, if x is out of the equation, only y set it into number, it's called a horizontal line. We already seen this. Okay. Now, one very special form of these equations is when m is 1 and b is 0. As you notice, this is also this one transformed into this by setting m equal 1 and b equals 0. That means slope is 1. Every unit you go right, you went up. Okay, slope is 1. And every x value actually returns to the same value itself. That's why we call it an identity function. Y equals x, or f of x equals x, is called identity function. Every x you insert goes back to itself. You knew it, right? Y equals x. But you didn't know the name, identity function. The third one we need to get familiar with is y equals x squared, or f of x equals x squared, quadratic function. Quadratic means, actually, I call that a square function usually, because it's nothing but a square, right? X squared. What is special about this graph is it just looks like a U-shaped object, and it's called, by the way, the technical name of this shape is called parabola. When I say parabola, you will recall x squared. Okay? This is often used, this is widely used everywhere. Here's graph. Any questions so far? Alright. The fourth one is kind of similar, we see. Similar shapes. If this looks like parabola, it looks like this part turned downward, and it's a lot steeper. This is quickly rising, this is kind of slowly rising, such as, and I put these, and by the way, it goes a little lower on this side, it goes underneath anyway. But this is called cube function, x cube, and its graph is this, almost inverted S looking thing. Everything okay so far? Are you putting these pictures on your mind? Cube, square, straight line so far? Okay. We'll refer back. If you, let me know in case you don't remember any picture, we can go back and cheat from this table. The fourth one is square root function, because what we have here is a square root. Square root of x, and it starts at 0. This is awkward. Doesn't have a much history. Doesn't have a left side. only it starts at 0 and rises slowly. Rise and rise and rise. In the infinite x, it rises up to infinite y values, of course. So it never quits rising. While cube root x almost seems this part's identical, okay? But this is kind of slower though. When you put these two on the same picture, this is look like more accurate. This is cube root x. But it also have a prior history like this one. So this is cube root x, this is just square root x. They are similar on the right side here. However, cube root x has symmetric picture on the left side. Same picture underneath x-axis on the left side, it happens as well. Alright? Okay, let's identify quick details about these functions. What's the domain of square root function? Doesn't say here, but in interval notation. What's the domain? What kind of numbers you're allowed to insert in this function here? Do you see anything negative? It's only numbers here, right? So how do you write all the numbers here? As an interval. All positive numbers starting with 0. What is this? 0 to infinity. Right? And range as well. This is the range when you look at, compress this to y-axis. This is range. And it starts at 0 and goes to infinity. So domain and range are the same numbers. Range, sorry. Range is the same as well. However, this one, what's the domain of this function? What's the domain? What kind of numbers are you allowed to enter? Everything. I can take a number and compute it through this function. So this is on the domain. That's on the domain. Everything on the left and right, entire line, is the domain. So I can pull any number from this set and use it. Range is the same as well. Range is this guy as well. So cube root x is really a flexible function. It takes in everything and brings out another number. But square root function is a little fragile. It doesn't work with every kind of number. It's very, very sensitive what kind of number you have inside. Anyways, these are the pictures though. Okay. This is almost look like this. What is the name of this function again? I just throw here. What is this green line?
Linear.
Linear function, more specifically its name is identity function f of x equals x, right? Look how similar these are. This is almost x. Somebody put protection around x. That means how is it going to protect x? It's just going to convert any negative number inside to positive side. It's exactly doing what it promised. There are negative numbers on this side, right? You plug in -3, it turns into -3 on the identity green function. But the blue one, the absolute value function, takes this, cuts it off, and inverts it. It's kind of lift this up and makes it positive. Okay? So absolute value function is actually, this side is the same as x, because positive things just turns to positive. You don't need protection around positive things. This side the same, but the other side is just break it and lift it up. That's how you form absolute value function. It's just a straight edge V shape, V. Okay? And the last one on the list you need to know is reciprocal of x, reciprocal function, 1 over x basically. It's just two identical shapes, symmetric with respect to origin, two shapes. One is going all the way down, starting from infinity all the way down. The other one is coming all the way from 0 and going to infinity. There is one odd thing about this function is, what happens if you enter the value 0 for x? This is 0. What value does it go? Do you hit anything on the curve when you plug in 0? It's almost tangent to the y-axis. It's almost touching it, but it's never really touching it. So there is no value you can compute if you enter 0. 1 over 0 is undefined. So reciprocal function has domain as 0 to infinity and minus infinity to 0, but 0 is never included in either piece. So there is a hole in the middle. Except this point, you pretty much cover everything. Reciprocal of function x, 1 over x, has domain as 0 to infinity and minus infinity to 0 union. But range is the same as well. It never becomes 0 in the range as well. It's up and down except 0. Alright, are we good so far? Now, once I tell you sketch 1 over x, you can do the sketch in 2 seconds, right? Because it's already given to you now. Question is, what if I change this equation or any one of these 8 equations slightly? Like add a number right next to x, or add a number after the entire formula, or multiply by a number. How do you quickly make the new picture from the old one? That's our topic today. Okay? I slightly changed the equation. How does the graph change? Okay, they are called transformations. The first 4 are called translations. In other words, right, left, up, and down shifts. They are called translations. Up or down shift, if you shift a graph up or down, it's called vertical translation. And this is the sign you need to look to determine there is an up or down shift. If there is a number, this is the main function given in the previous pictures, given earlier, given in early 2 slides. One of the 8 things. You will be given one of the 8 equations here, but somebody added a nasty number to the end. Like you have absolute value of x and then plus 10. How do you change that V shape? It says if that number is positive, you just need to move that shape 10 units up if you see 10. But if you see minus 5, negative 5 on the very end, you just need to move it down 5 units. Does it make sense? Plus is up, minus is down. This is very simple. Here is why it's happening, because when I add a number to the very end, the final product is always 2 more. 6 to 4 to 6, 0 to 2. Kind of every point here, this is supposed to be 1 earlier. Now it's reading as 3. Look, every point jumps up, moves up, right? 0 moves to 2. Negative 1 moves to 3. I'm sorry, positive 1 moves to 3. This 3 moves to 5, for example, somewhere here, okay? No, it moves here. supposed to be going a little bit that point, but oh, that's not. That's 3. That's 5. Yeah, this should go to the right. Anyways, it's not like that. What if we have a negative? You move every number. Look at the negative one. 4 units down. 9 to 4, 4 to 0, 4 to 0 again, 9 to 5. You take off -4. You bring every number. This goes 4 units down, and this goes 4 units down. This goes 4 units down. You move every number 4 units down. Okay? Now, here's our first 2 questions. Can you make the pictures of root x minus 4 from 1 over x minus 4 from scratch? Alright, if you don't mind, I'm going to change this one because they are pretty much the same. I'm going to make this 1 over 2, 1 over x plus 2. And in your set it's probably different anyways, okay? It's not the same in yours. Okay, you need to first identify the main function. What is this main function? What is the name of it? What is the picture of it? You need to go look up if you don't remember on top of your head. Do you know the picture of root x?
Right.
What?
Parabola.
Parabola?
Parabola, yeah.
Parabola is something else, I think. Where is parabola? This is parabola. This U shape. Right? It's x squared, the parabola. So root x is this guy. So first, several times you may need to go back to this table and look up these pictures. This is root x. Okay, so you need to start with that. Make a picture of this guy. So it starts with this, and goes slowly up. Right? This is root x. I put it in dash line because this is not the final answer. This is just the picture of root x. What kind of shift -4 is? Just name it. Right, left, up, down.
Down.
So far you know only 2 directions, down. So you just need to move this 4 units down. And for this, I recommend take a pivot point, reference point, and literally show how it's moving, such as what is the most significant point on this line? Starting value. And what is the name of that point or coordinates? That's origin, 0, 0. If you move it 4 down, what is the new location of it? Move 4 down. 1, 2, 3, 4 here. What is it called? 0, -4. Y coordinate will be 4 less. And then complete the rest. Something like this. If possible, give more points, such as, mark another point, such as I know what 9 is. What is this? What is the value of 9 under root x? Enter 9 into root x. What do you get? What is root 9? 3. So this is 9, 3. What it will be the new one? So you see, I'm wrong. Because if I move 4 units down, where is it gonna be? Where is the new location? Take 4 off. 9 comma -1. 9 comma -1 is here. So you see, I was too high. I jumped off quickly. So I'm going to fix it. This is not correct, sir. I need to go here to there slowly. Okay, and then eventually you will cross this thing. Well, if you pick more and more points, you will get a better and more specific picture. Well, was the earlier really terribly wrong? No, you still get full credit. I see the behavior, you shift it down, but this is more accurate. Okay? Any questions? How about this one? All right, first name 1 over x. It's what's the name of this one? Reciprocal. It's just these two lines, right? Two curves like this. All right. Now, how does these pictures change? It will move up to. This means up 2. So I will lift all these points 2 up, such as this one go 2 up, 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 etc., etc. Okay, this one everybody will move 2 up. And it will be a picture like this. No, it won't touch this 2 up. Well, it will still be correct. Okay, needs to be more spacing here though. But I think you got the idea. Alright. Any questions? It's alright. When you go to your homework though, you have a great help in the homework. Please don't use that help. Because in homework, it just wants you to pick the final picture. Some may think, oh, I don't have to do anything on paper. No, that's not, this picking the right option here is not the right way of doing it. First, as I did on the paper, do the question from scratch without picking at these solutions, then come back and choose the right option. So what is the right option now? It looks like a down picture like this. In this one, and starting value is 0, -4. So which one is right? A, B, C, D? It's C, right? It's starting -4 and rising. So these are multiple choice questions. Seems like, but you need to make them a show work type question. Don't use the choices until the last moment. Okay? Alright. We just learned left up and down shift. It's time to learn right and left shifts. This is extremely important. Most people are confused by this. What's the difference between this example and this one? Here I have a 3 after x squared. Now they have a 3 right beside x under x squared. Do you see the difference? Do you see any difference? What? There is a parenthesis and kinda there is a well, what's the main function? What is the parent function here? This one deformed from a parent function. Which is x squared. They both emerged from the same mother function, x squared. Somebody only added 3 to the entire function. Look, I still see entire function here. They just increased y values. Because when somebody give me x, I square it, I get a y value. It looks like they just jumped y values 3 units up. They shift directly y values 3 more. Here though, you are first increasing x values. Look, somebody give me some x. I'm increasing them. Instead of 1, I'm making them 4 and then squaring it. So here this number is directly changing your x values. Immediate effect is on x. Here the effect is on total y values. Total main function is first computed, then you're increasing it. Here, before computing the square, you're changing x's. Do you see the difference? So how do I know the difference again? If you see a number directly x inside the main function, inside it, incorporated into x, then it's no longer up or down shift. This is an upward shift. This is no longer up shift. It's either right or left. How do I know which way? From the graph, it's obvious. If I add 3, my starting value shifted to left. So adding a number to x shifts the picture to which direction? Left. Left. Okay? To your, now, to my right, but to your left. Okay? Good? Left direction. But what if this is a negative number? If it was negative 5, it would shift it into, if you have a negative 5, it will shift to right. If you have, let's say, h of x equals x minus 5 squared. Got it? So here is the summary. Once, look where the number is. It's no longer in this description. The number was add of f. You compute f first and then you add a number. Here, the number is right incorporated to x. It's affecting x values. And here too. If you have a plus a number, it shifts left. If you have a minus the number x, then you have shift right. Got it? Alright, exercise. Make this picture, or at least describe what's going on. Anyone? First, describe the main picture. What is the main function here? Let's compare it. F is always for the main functions, one of the 8 ones we've introduced. What is the main function? It is absolute x. Which one is this? Similar to 1 out of 8 options. Very first 2 slides. It's absolute x, right? It doesn't have a square. It's not reciprocal 1 over x. It's not linear function because you have bars. This looks like very similar to this. So start with absolute x. And tell me what happens to this picture, quickly. When you have minus 3 added, included with x, minus 3 incorporated into x. It shifts to the right. Are you sure?
Yeah.
Is it negative to the left side? No, it's always opposite with axis. So it shifts right. If this is 0, it's going to be 3 right. This is 0, 0. And its new location is 3, 0. And you're going to make a V shape there, and that's it. Make sense? Okay. Now what's the situation here? What is different this time? What's that? What's new?
Is that your right, so you have 4?
Okay, that's the right answer, but what is different? What's happening for the first time? Hmm?
Translations.
We have two type of translation happening at the same time, right? Two in one problem. What are they? You have one here, another one there. Two numbers added, subtracted. You just need to identify what each does and do it together. So what does minus 3 does?
5, 3.
What?
5, 3.
This is right shift. It's just we just finished it, right? Right 3. How about this one? Up 4. So just do that to this guy. Well, does it matter which one I do first? Should I up 4 and then bring right? Or should I first bring right and then go up? Which one is first?
Doesn't matter.
Doesn't matter. I mean, what happens if you go 3 miles east and 4 miles north versus you go first 4 miles up, 3 miles east, you end up in the same location, correct? So for translations, order does not matter, but we will learn stretch and shrink and reflections. Order will matter later. Right now you're safe. Okay? So I will go first 3 right and make this guy here. This is 3 0. 3 right. And then 4 up. I'm going to move it up 4 units. So we go 1, 2, 3, 4, let's say here. 4 up. And start your V shape right there. That's it. This is B of x equals x minus 3 plus 4. Okay? So far so good? Now we're starting 2 more transformations, shrink and stretch. Okay, let's analyze this table. It's again our famous function absolute x. These are regular values. If you insert minus 3, minus 2, minus 1, 0, 1, 2, 3, what's happening? Every time I enter a negative value, absolute value turns it into positive. No change in the digits, 0, 1, 2, 3, 0, 1, 2, 3. It's just making positive. Okay. Now somebody put 2 in front of it. 2 in front of the entire function. What happened? Every digit doubled, right? Except 0. 0 doesn't double. Everybody doubled. Okay? If I put 1/2 though, or in other words 0.5, this is the same as 0.5. Kinda small, isn't it? This is kinda big. Like your wage. If I multiply your wage with 0.5, you get less wage, right? I mean, most people think, oh, you're multiplying something that I must be earning more, but no. Depends on what I'm multiplying with. If I'm multiplying with a small number less than 1, your wage shrinks. If I multiply your wage with a number more than 1, even 1.1 matters, then your wage stretches or gets bigger. So that's exactly what's happening here. This is regular function, original. When I multiply it by 2, everybody doubled. The difference here seems not so much. Like if you're earning $1, you will start making $2, not major change, but Look at now this number, for example, 2. Instead of you're making 2, you will be making 4. $2 raise. It's a lot, right? So the difference gap starts opening more and more. It's a stretch. Most people think this is an upshift. This is not a shift. Shifts happen in the same scale for everybody. Everybody gets $1 raise. That's shift. But this is not somebody making $2, making 4. More shift if you go more and more to the right. So we call this not a rise, we call this a stretch. Like there is a rubber band here, you really stretch it up. It's nailed here. By the way, this is very important. Any value on x-axis stays on it. So like if you're not making any money, $0, no matter what I multiply with, you're still making $0. So you don't get any raise. So if you have at any point on x-axis, never increase them. They are kind of nailed. And then there is a rubber band here. You're pulling it up. It's stretch. You let it go. It's going to get shrink. It's going to go lower. And thus lower values happen if number here is less than 1. Less than 1. Okay? If it's exactly 1, no change. But even 0.99 is a little bit of shrink. Okay? 0.99 even makes it down. Does it make sense? So when this happen, if you see a number in the very beginning of the function, entire function, not inside or somewhere else later, there will be multiplication somewhere else. We don't care about it. It only counts if it's in front, affecting the entire function. Okay, here are 2 examples. This was easy. It's just like 2. This is going to be 5 times the regular. This is the regular. It's 5 times steeper. So I will just go steep angle and we'll be done with it. Right? Any questions on this one? This is more than 1, so it's a stretch. I just stretched it. Okay? How about this one though? X squared is this one. It's parabola. This is x squared, correct? And 1 over 5, what does 1 over 5 do to it? Yeah? Oh, this is a big number, 5, so we're just gonna stretch it, right? Correct? Now look at the final product. Divide this 1 and 5. It's 0.2. It's less than 1. Once you end up with a less than 1 number, we go really down and make this picture. Alright? I mean, it's perfect if you could give me some number representing what's going on here, like this one. This is like, take a number here, 2 for example, and this would be 4. What is the new number gonna be? This is 2, 4. The new number is gonna be still 2. Look, its x coordinate is 2. X is, okay, vertical stretch and shrink. X never changes. X is still 2. But what will be the y? What is the new y value? No, it's not 2. This used to be 4 earlier. So it is 1 over 5 times 4, which is 4/5 or 0.8. You divide whatever number you see here by 1 over 5. That's the new change, right? Okay? Or literally put 2 here. 2 squared is 4. 4 times 1 over 5 is 4/5. Okay? Make sense? You're awful quiet. I'm kind of worried. Are you getting it?
Yes.
Okay. So how many we have total? Up, down, left, right, shrink, stretch. These are vertical. You're shrinking up or down, kinda up and down, stretch and shrink. 6 in total. You think it's over? No, we keep going. Okay. There is also horizontal shrink and stretch. We already did this. This is done. Now we are gonna mention horizontal one. By the way, all I said on pictures are here. If you have a number more than 1 in front of the main body of the function, it's a vertical stretch. If you have a number which is less than 1, but positive, because you don't multiply with a negative, only positive, then it's a vertical shrink. This has already been said. What is new? How about we do this horizontally? Where do you think the number will show up? Again, if the number shows up before the entire equation, it's vertical. But the number only shows up wherever x's are right before x, like they are touching each other. Here they are not touching each other. Sorry. They are not touching each other. There is a barrier between them. This is the main function, and 5 is affecting the main whole entire function. Here, they are glued together like this is what I mean. 5 is inside next to x. Okay? If I take this 1/5 and put it under x under the square, this is horizontal. Horizontal, this is vertical stretch or shrink. Vertical, when I put 1/5 inside x, it's horizontal. Got it? However, it's not just the name change happens. The final effect also reverses. Like if this is a big number, you see a big number here like 5x next to x under the square, for example, then you're actually shrinking it, horizontally shrinking it. I will explain it on the next example better. I will show it. But if the number is small, you are horizontally stretching it. Okay, you will understand better in the next one. But let's first read the statement. Big number next to x, we are shrinking it horizontally. Think horizontally though, sideways. You are shrinking sideways. It's actually opening. And if you're and then stretching horizontally if the number is small, as described on this one. Okay, let's take a look at this example. Go back to problem next. Look, please take a moment. This is just an example directly out of the book, but it explains the effect really well. First, where is the number multiplied? Where? Is it outside f or inside f with x? In both parts, this is the number. Where does it show up? Inside, right, glued to x. So it's directly affecting x values. So I'm expecting some kind of shift or shrink or stretch sideways or horizontal. It's not vertical. Okay? Look what's going on. When I have the big number, what happened? Everybody get like smashed, stretched. I'm sorry. It's kinda, this was getting these two pieces was really tense. Look, it was 2 units away. You let it go and it got loose, and you're only 1 unit away from this distance. This was really tense. This is loose. So it's horizontally shrunk. Look, this was really, you were keeping it apart. and we're holding it with force, and then you leave it, like your bodybuilding devices, okay? That stuff. It's just like, but just you need to think horizontally, all right? Here, small number took this regular size shape, and then you really stretch it apart. Look, this is really stretching, stretch, and stretch. Okay? How did they discover this? Because it's so confusing, right? Well, wait, is big number, does it make closer or wider? It's confusing, I know. There is a test you can make though. Just take these coordinates of the numbers and apply what it says to them. Like this is sitting at 4, right? Sitting at 4. Just twice, 2 means I know it's going to be shrinking half. So it's going to be 2. It's going to 2. This was sitting at 2 units away, right? 2 units. Now it's sitting at 1 unit. Okay? And this is complete opposite. This was sitting at 2. This is minus 2 something. But now it's minus 4 something. It's twice longer now. Stretched. You need to be able to compute the same value, you need to put twice more x, 4 here to get minus 2 effect. Okay? Alright. Do what I said to this picture now. Okay, first thing. For the beginning of your problems, keep this beside you. You need to have both. Now, take the statement and check where the new number is. Okay, by the way, this picture belongs to this guy. This is the picture of regular function, and somebody added, multiplied each and every x by what kind of number? Determine what kind of number is this, small or big number? It's a small. It's less than 1. And go check from the table the effect. You don't have to guess it. Just agree. What happens if I see a small number next to x? Go check out the table. Alright. The number is happening next to x, so these are not the cases. Right? These are numbers outside the x before f. Okay, so it's not vertical shrink or stretch. Very well. Then we check out horizontal. Do you see the numbers next to x? Yeah. It's either one of them. Which one was it? Small, right? Smaller than 1. Then read the effect and make that effect on that picture. What does it do? We need to stretch horizontally. Stretch horizontally. Stretch horizontally. That means stretching horizontally means you're going to pull from those pieces and make it apart. So I need to pull all these points going right and left. Stretching horizontally means you need to expand it to the right and left. How? 3 times. 1/3 means 3 times larger. This is the scale. That means 3 times. Every point will move 3 times to the right or left. Let's check. What is the coordinates of this point? 1, 2, 3, -3, 0. Who can tell me the new location if this point is stretched 3 times to the left? What is it?
-1.
Stretching it. If you make it -1, you're shrinking it. It gets closer, it gets loose and shrinks. You're shrinking this picture. Stretch. So, it's not -1, it's what? -9. This will become 3 times only x coordinates for horizontal stretch and shrink, only x coordinates change, y stays the same. So it's going to be 3 times minus 3, which is minus 9. Where is minus 9? 4, 5, 6, 7, 8, 9. There you go. This went all the way here. Okay? There are 4 marked points here. How about this one? This is minus 1, 0. Where does minus 1, 0 go? Negative 3, 0. Where is negative 3, 0? There we go. Okay? How about this one? 1, 0. Where does 1, 0 go? Oh, it needs to go left because everybody going left, right? No, shrink and stretch means they go opposite ways to the right. Right guys go to the further right. The stuff on the left goes further left, but this is right, sorry. Right goes further right, left goes further left. So 1, 0 goes to 3 times 3, 0. 3, 0 goes to 4, 5, 6, 7, 8, 9, 0. Agree? Now combine those 4 points. It was connected by lines, so I will connect them by lines as well. And connect these 2 dots by lines. And connect those 2 by lines. By a straight line, actually, single line. Do you see something really enlarged, stretched? Then you did the right way. Because that's what it says. Stretch happens, although it's a small number, stretch happens because it's happening right to x. Okay? Alright, are we out of time? Almost. So I think this is a good spot. We're almost past a little bit halfway. We will show more. Okay? We will start combining these transformations next tomorrow. You too.